Hey, this is Nomad. I'm going to be taking you on an adventure today in space. You've probably heard of black holes, but have you heard of white holes? These are notes I've taken in studying conformal cyclic cosmology. In general relativity, a white hole is a region of space and singularity that cannot be entered from the outside. However, light and information can escape from it. In this sense, it is the reverse of a black hole from which energy, matter, light, and information cannot escape. White holes appear in the theory of eternal black holes, in addition to a black hole region in the future, such as a solution of the Einstein field equations. They have a white hole region in its past. This region does not exist for black holes that have formed through gravitational collapse. However, nor are there any observed physical processes through which a white hole could be formed. Supermassive black holes are predicted to be at the center of every galaxy. Stephen Hawking has proposed that these supermassive black holes may spawn a supermassive white hole. Like black holes, white holes have properties like mass, charge, and angular momentum. They attract matter like any other mass, but objects falling toward a white hole would never actually reach the white hole's event horizon. Imagine a gravitational field without a surface. Acceleration due to gravity is the greatest on the surface of any body, but since black holes lack a surface, acceleration due to gravity increases exponentially, but never reaches a final value as there is no considered surface in a singularity. A black hole emits Hawking radiation, coming to thermal equilibrium with a gas of radiation. Because thermal equilibrium state is time reversal invariant, Hawking argued that the time reversal of a black hole in thermal equilibrium results in a white hole in thermal equilibrium, each absorbing and emitting energy to equivalent degrees. This bridge can either connect two black hole event horizons in each universe, with points in the interior of the bridge between the parts of the black hole region of space, or two white hole event horizons in each universe, with points in the interior of the bridge being parts of the white hole region. It is impossible to use the bridge to cross from one universe to the other, however, because it is impossible to enter a white hole event horizon from the outside, and anyone entering a black hole horizon from either universe will inevitably hit the black hole singularity. Black holes that form at some particular time from a collapsing star would require a different metric. When the infalling stellar matter is added to a diagram or matrix of a black hole's history, it removes the part of the diagram or matrix corresponding to the white hole interior region. The equations of general relativity are time reversible. They exhibit time reversible symmetry. General relativity must also allow the time reversal of this type of realistic black hole that forms from collapsing matter. The time reversal case would be a white hole that has existed since the beginning of the universe and that emits matter until it finally explodes and disappears. Permitted theoretically, they may only exist if they were built in the initial conditions of the Big Bang. It is predicted that such a white hole would be incredibly unstable in the sense that if even a small amount of matter fell towards the horizon from the outside, this would prevent the white hole's explosion as seen by distant observers, with the matter emitted from the singularity never able to escape the white hole's gravitational radius. Depending on the type of black hole situation considered, there are several types of white holes. In the case of a Schwarzschild metric, a geodesic coming out of a white hole comes from the gravitational singularity it contains. In the case of a black hole possessing an electrical charge or an angular momentum, then the white hole happens to be an exit door of a black hole existing in another universe. Such a black hole, white hole configuration, is called a wormhole. However, it is not possible to reach the region in the white hole, so the behavior of it, and in particular what might come out of it, is impossible to predict. A white hole is a configuration according to which the evolution of the universe cannot be predicted because it is not deterministic. In its mode of formation, a typical black hole comes from a residue of a massive star whose core contracts until it turns into a black hole. Such a configuration is not static. We start from a mass, an extending body, which contracts to give a black hole. The black hole does not exist for all eternity, and such there is no corresponding white hole. To be able to exist, a white hole must either arise from a physical process leading it to its formation or be present from the creation of the universe. There is no known observable astrophysical process that can lead to their formation, and if they did form, after forming would more than likely collapse and become black holes. Some researchers have proposed that when a black hole forms, a Big Bang may occur at the core or singularity, which would create a new universe that expands outside of the parent universe. The Einstein-Cartan theory of gravity extends general relativity by removing a constraint of the symmetry of the affine connection and regarding its asymmetric part, the torsion tensor, as a dynamic variable. Torsion naturally accounts for the quantum mechanical intrinsic angular momentum, or spin, of matter. In the Einstein-Cartan theory, however, the minimal coupling between torsion and Dirac spinors generates a repulsive spin, interactions that happen in fermion matter at extremely high densities. Such an interaction prevents the formation of a gravitational singularity, and instead the collapsing matter on the other side of the event horizon reaches an enormous but finite density and rebounds, forming an Einstein-Rosen bridge, or wormhole. The other side of the bridge becomes a new, growing baby universe. For observers in the baby universe, the parent universe appears only as a white hole. Accordingly, the observable universe and the Einstein-Rosen interior of a black hole existing as one of the possibly many inside a larger universe. The Big Bang was a non-singular big bounce at which the observable universe had a finite, minimal scale factor. The Big Bang itself may be a white hole. The emergence of a white hole, which was named a small bang, is spontaneous. All the matter is ejected at a single pulse. Thus, unlike black holes, white holes cannot be continuously observed. Rather, their effects can only be detected around the event itself. In this way, information could be passed from different universes at different times through cosmic microwave background radiation and/or gravitational waves. Thank you for watching. This has been Nomad.